Hello dear students, welcome back. This is again Jayalakshmi of IK College of Engineering. Now we are going to discuss that second part of our video, that Unit 1 day introduction. Let us start with what we are going to discuss in the Unit 1. We are going to discuss complex systems and microprocessor used in embedded system and embedded system design process, design example, and we will discuss about that model train controller and that quality assurance technique, designing with computing platform, consumer electronics and platform level performance analysis in the next video. Let me start with that one. What are all the attributes of an embedded system? It needs computational power. It needs more power for computation work. The processor needs some power for processing, and the memory needs some power for refreshing. So when you are going for that one, it need more power for responding real-time inputs also. Similarly, the memory, the size of the memory is another one important attribute when you are designing an embedded system. The size of the memory should be very small, because as we are using very compact devices as a embedded system devices, that needs very less memory size. Real time, as you are applying these embedded system devices in real-time application, there is a limited period time for responding. Okay, next, communication, receiving an input, processing the input, and then provide the output. It will take more time, but our responding time should be very less compared to that processing time. Okay, so we have to concentrate on that also. And take dynamic decision, that processor has to take decisions based on the previous history of the outputs. Okay, next we are going to discuss that challenges in an embedded system. What are all the challenges we are facing? Already we have discussed that in the attributes itself, that is limited secondary memory, size of memory should be very less, limited processing power, and interaction with hardware that needs more power, as well as more number of hardwares we cannot utilize when you are going for designing an embedded system. Then absence of standard I/O devices. If you are using a washing machine, there is no keyboard as you are using in PC. So there is absence of standard I/O devices. These are all the challenges we are facing when you are going for embedded system. Next we are discussing about that embedded system hardware. As you have discussed in the microcontroller, the same parts existing here also. Other than that, we are in need of some serial ports, parallel ports, and I/O devices for communication, special tracking, that is GPS devices. These things has to be added with that embedded system hardware. Next we are going to discuss about the processor used in embedded system. We are going to use a general purpose processor like your 8051 or 8086 like that, and some embedded processor also you can use, or you can use a digital signal processor or media processor. These are all some general purpose processor we are using. Without that DSP you cannot process your photo. When you are taking selfie now, when we are using that face beauty mode, that time if you are not having any digital signal processor, that is not possible. So when you are going for that selecting a processor for your embedded system, you have to choose one particular, what are the processor you need, you have to choose this. Other than that one, we are having application specific system processor, application specific instruction processor, and then application specific instruction core processor, and then ASIC designing. We are designing our own design using ASIC and VLSI. Next, we have to go for the characteristics of an embedded system. The main thing we have to concentrate on that characteristics of the embedded system. When you are designing an embedded system, it needs complex algorithm, because using very less memory size and real-time operating system, you have to solve very complex programs. So we need complex algorithm. It should be user interface. If you are going to use a mobile phone, it should be user interface. Okay, without the knowledge of touch screen, without the knowledge of keypad, we cannot use a mobile phone, a smartphone. Okay, so it should be user interface, that it should give some ideas how you have to use this one. And then to make things more difficult, embedded computing operation must often be performed to meet deadlines. The timing is very important. If you are not giving your OTP within a given timing, you cannot process further. Okay, that is another one difficulty we are facing here. Then real time. Now all the embedded systems are mostly used in real time, so it has to meet the deadline. For that one, your embedded system has to be designed in such a way, and it has to support multi-rate devices. We are connecting multiple devices which are operating in different rate speed. So when we are connecting that device, we have to concentrate on these things also. Next, manufacturing cost. And then we have to concentrate on the cost for manufacturing that device, as well as cost. That cost include the raw material cost, labor cost, as well as and the timing duration up to which it takes to bring that to market. That things also consider when you are designing the embedded system. Next, power and energy. That power needed to process the given data, that things should be very considered. Okay. Next, design process of an embedded. What is design? Design is a process that is used to systematically solve problem. What is design process? A design process is a systematic problem solving strategy with criteria and constraints used to develop many possible solutions to solve or satisfy human needs or wants, and to narrow down the possible solution to one final choice. Okay, we have to design a device embedded system that should solve the needs of the people. With so many solutions are there, we have to find out which is the best solution. That is the design process. Next, what are the steps we have to follow in that design process? We are having two models in that one, top-down model or bottom-up model for doing our design process. Let me show that one. Here is the top-down model. For each problem, we need some models for that one. Here is the top-down model. This model solves that from the requirements. You have to find what are the requirements of the people. Then you have to give the specification of your system. Then you have to design the hardware architecture as well as software architecture. Then you have to give the integrated design. The entire thing, hardware and software, has to be integrated together, and they have to be tested for the needs of the people. Then finally we have to give the output to the people. This is explained in the further designing. Okay, what is abstraction, what are all the specifications are there. Requirements means what is the need from the customer, that has to be noted and it has to be documented for further reference also. In that requirements, we are having functional requirements and non-functional requirements. Functional requirements means the final output. Non-functional requirements, the time to compute the output, power consumption, cost, size, weight, extra are the non-consumption requirements. Then when you are going for that specification, you have to give the specification, that is more description of the system. It has to include functional and non-functional elements of the system. It should be understandable enough. It should be unambiguous. Okay, a wrong specification leads to wrong functionality that fails to meet the requirements of the people. Next, after specification, we have to go for that architectural design. Here I have given some example for that hardware architecture and software architecture design of an automatic temperature monitoring control system. See that one, the hardware blocks has to be designed first, and we have to go further that circuit diagram of the design. Then we have to write down the program for that one. Here I have given some flowchart for that diagram, that is program. Okay, so we have to go for hardware design as well as software design. Next, we have to go for the integration of the entire system. First, we have designed the hardware. Parallelly, you have designed the software. Both of them should be combined together, and we have to test it for our output, whether it meets the customer requirements or not. In the next unit, that is in the next video, we will discuss about that example for this design as model train control unit. Thank you.